Hello, everybody. Today we're going to look at lesson 2.2a at WAMAP, which is Reducing Fractions, Introduction to Fractions. So we're going to start learning about fractions today. And the first lesson is using visual representations of fractions and telling what fraction this would be. Okay, so in a fraction, you have a numerator and a denominator. Let's see if I can do this. All right. You have a numerator, which we'll write n, and then a line and a denominator. And the numerator kind of sounds like it's a numbering thing. Well, it is. The numerator counts how many pieces there are in a fraction, and the denominator tells you the units. That's the denomination. So, for example, in this case, they are saying represent the shaded area in the drawing with the appropriate fraction. So what we need to know is how many pieces there are total, which will give us the denomination, the denominator, and then we have to count the ones that are blue, the ones that are shaded, and that number will give us the numerator. So the easiest way, well, you can count the individual squares if you like, or you can just count them across 1, 2, 3, 4, 5, and then count them down 1, 2, 3, 4, 5, 6. So we have a grid that's 5 by 6. And if you're up on your multiplication table, you know that 5 by 6 or 5 times 6 is 30. So we have 30 of those little squares. And then how many are shaded? Well, we've got 1. I don't know this. 2. We can't probably write 3. Yeah, it's not going to work. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 of those. We have 12 pieces. And there's a total of 30. So 12 out of 30. Okay. So 12 over 30 is what we write. And the blue area represents 12/30ths of all of this. And then with fractions, we always want to reduce or simplify as far as we can. So let's take a look at how this fraction would simplify. We're going to do something called the, you guys have already been working on this, prime factorization. And we'll just use a factorization tree. And we're going to start with the smallest, let's see, 2 smallest primes we can think of. 2, 3, 5, 7, and 11. So these 5 will get you through most of it, but try to memorize the first 10 or so. So 12 divided by 2 is 6. And 6 will also divide by 2. So we want to use the smallest primes we can first. And then we will figure out this 12's prime factorization is 2 times 2 times 3. And this is how you can restate 12 using only prime numbers. And this is going to be a useful tool. So we're going to write 2 times 2 times 3. That's our numerator. That's the 12. So we are just restating the value of this fraction in using a prime factorization. 2 times 2 is 4, times 3 is 12. So we're not changing the value at all. We're just breaking the number down. We're analyzing 12 to make it easier to do this problem. And now we've got 30. We're going to do the same thing. Oops, now it's not writing. Maybe I'm too far off the page. Let's see what I can do. 30. Nope. 30. All right, I think I ran off the edge, and there's no clear edge from where I'm sitting. So let's see if this is going to work. I'm going to erase these primes. Just remember 2, 3, 5. I think we won't need any more than that. And then we'll go back to drawing and get a nicer color. I think I'll use orange. My high school colors were orange and blue. So we've got 30 here, right? So 30 can be divided by 2, which is our smallest prime, leaving 15. And 15 can be divided by 3, leaving 5. Now we have 3 prime numbers. 2 times 3 times 5 is 30. This is the prime factorization. We're going to write this below, the prime factorization for 12. All right, so 2 times 3 times 5. And so now we can simplify this fraction very easily. This is equivalent to 12 over 30. We've written it out this way. And by taking the prime factorization, we've broken this down into the smallest possible prime numbers that you can use. And now 2 over 2, we have 2 over 2, and 2, this is also like 2 divided by 2. 2 divided by 2 is 1, so we can cross out these two. They would leave 1 on the top and the bottom. And then we have 3 on the top and 3 on the bottom. And this is kind of like a game of Go Fish. Do you have any 2s? And you get 1. Do you have any 3s? And then I look at the next 2. Do you have any 2s? There's no more 2s on the bottom. And then the 5 in the denominator can say, do you have any 5s, in the numerator? And by reducing these numbers to the equivalent of 1, we end up with 1 times 2 times 1, which is 2. Oops, I'm at the edge of the paper again. And then on the bottom, we have 1 times 3 times 5, which is 5. Because this 2 and this 3, they divided into the 2 and the 3 in the numerator and became 1. So we can just take the numbers that are left, and in this case, we only had 1 number in the numerator and 1 in the denominator, and that becomes our simplified fraction. So 12 over 30 is the same as saying 2 over 5, or 2 out of 5. So in this picture, 2 out of every 5 of these blocks is blue. And the 2 and 3 we crossed out. If you multiply 2 times 3, you get 6. So what we ended up doing basically was dividing the top by 6 and the bottom by 6. And we got 2. 12 divided by 6 is 2, and then 30 divided by 6 is 5. So if you don't do this prime factorization, this division turns into kind of a guessing game. And once you get good at it, you can do that and do pretty well. You can see these numbers are both even. So if you divide by 2, you can see what you get. And we would have gotten 6 over 15. And then you would need to see, 6 and 15 can both be divided by 3. And then you would get 2 and 5. But it's very easy and to do it this way. And you should practice doing prime factorizations because we're going to be using these in the future to determine other values. Least common multiple and greatest common factor. But for right now, we're just going to simplify fractions with these. Write the equivalent as a fraction and then cross out. You can play Go Fish. Do you have any 2s? Do you have any 3s? Figure out the equivalent smallest fraction. So the smallest fraction that is equivalent to 12 over 30. All right. Let's, I'll do one more very quickly. This drawing is 1, 2, 3, 4, 5, 6 across, and 1, 2, 3, 4, 5 down. So we've got 30 in our denominator. And then we're just going to choose or count the blue ones. 1, 2, 3, 4, 5, 6, 7. 7. Okay. So 7 over 30, or 7/30th, is the fraction representing this picture. So this time, if we try to do a prime factorization, we get 7. And 7 is already prime. And then for 30, we can use this prime factorization up here. We'll get 7 over 2 times 3 times 5. And in this case, when we play fish here, do you have any 2s? The numerator can ask the denominator, or vice versa. Do you have any 3s? No. Do you have any 5s? No. And the numerator can say, do you have any 7s? And no. So this number, we would just, this is 2 times 3 times 5. We would just write this out as 7 over 30. And this is the lowest This is the smallest fraction. So it's already reduced. So count up your total, like calculate the total or count up the total squares for the denominator. That'll be your units. And then count up the number of shaded blocks, and that'll be your numerator. If you can reduce it, write it in lowest terms. So let's try these out, see if we get these right. We had 2/5 for this one. Oops, need to stop. Turn that into a mouse. All right. So we had 2/5 here. Let's submit this one. Okay, that worked. And then here we had 7/30. 7/30. And we'll submit this one. So it's basically knowing how to count the little blocks here, and then knowing how to stack them and simplify. So those are the 3 skills you'll need. Give it a try, and if you get stuck, let me know.